Hey guys, in this lesson, I'm going to cover Docker containers and microservices. And this comes before we get into the Amazon Elastic Container Service, ECS, because ECS is a way that we can run these Docker containers on AWS. So firstly, what is a container and how does it compare to virtualization? So we've already seen the virtualization stack. That is a server with a hypervisor layer on top, which creates a layer of abstraction so that you can run multiple virtual servers or virtual machines, also known in AWS, of course, as EC2 instances. So here we have a virtual machine which has some virtual hardware, and of course it has an operating system, Windows or Linux, for example, and then some kind of application, service, or website running on top of it. Now, that all needs maintenance. Here we have to maintain the operating system, we have to maintain the application. So every VM, every instance needs an operating system, and that also has a significant amount of overhead. If you can imagine that on this virtualization platform, maybe on this one hypervisor server, we could be running tens, if not hundreds, of virtual instances on top. And that's a lot of overhead because each of those has its own operating system. It's a lot of maintenance as well. So here we have a container stack. So we still have a server underlying it. We then have an operating system. Could be Linux, could be Windows. On top of that operating system, we run the Docker engine. So here is a layer of software. So now we have a bit like a hypervisor, we have some layer of abstraction on top of which we can run the containers themselves. So now what we do is we run our containers. Each container includes all the code, settings, and dependencies for running the application. But it's not an operating system instance. There's only one operating system here, but we're running multiple containers. Each container is isolated from other containers. So you can see we're running lots of different types of applications. The containers start up really quickly, much faster than an instance would on EC2, for example. And that's because there's less to start up. You're not booting up an operating system, which can take significant time. So here we have lots of different containers, and they're all very resource efficient compared to virtual machines because we don't have that overhead of the operating system. So they use less resources and they start up much faster. Docker utilizes containerization to package an application and its dependencies into a single container image. Docker also provides the Docker Hub. That's a cloud-based registry service where you can store and share your container images and automate workflows for deploying those images. Containers are lightweight because they share the host system's kernel, so that part of the operating system, which of course utilizes quite a bit of overhead on the server itself. So Docker is ideal for microservices architectures and building cloud-native applications. So what exactly are those? Well, here's an example of a cloud-native application. With cloud-native applications, we're leveraging the best of the cloud. So we're able to deploy things like microservices architectures where the applications are constructed of loosely coupled components. That means that we're separating different components of the application and deploying them individually. Here we can see we have the customer service. That's actually running on Amazon ECS. So this is Docker containers, what we're talking about in this lesson. But you can also run Lambda functions as well. Those could be separate parts of your application. So a segment of the code here is the shopping cart. This is running authentication. This one here is the customer service component of the application. And then we've got the payment gateway. All of these are running separately from each other. So we're utilizing containers and functions. The code is running in Docker containers and Lambda functions where it's isolated, it's elastic, and it's cost efficient. If we have to update any individual component of the application, then it doesn't affect the other components of the application because they're separate. We have programmable, API-based inter-service communication through APIs. We're leveraging things like message queues for storing information as it's passed between different components of the application. We're utilizing a REST API here. We're utilizing things like DynamoDB tables and notification services. So we're leveraging all these different components of the cloud to build this cloud-native application. It gives us a lot of advantages both in cost, security, elasticity, and also from an operational perspective in terms of things like updating our applications because we have these separate microservices. So some of the attributes and benefits of using microservices are we get to use APIs. So everything in the cloud has an API. That means we have those common languages that we can write into our code in order to integrate the different components of our application. And loose coupling so that we're separating those components so they don't have those close interdependencies on each other. We have independently deployable blocks of code. That means that they're separate from a maintenance perspective and scaling is separated as well. Some components of our application might have more traffic than others, and they can scale easily and elastically and independently. We have a business-oriented architecture, so we're deploying around different business capabilities. It might even be different teams that are deploying different components of the application, and they might be using their own programming frameworks that are separate and different to each other. Therefore, with the APIs, we can still integrate together, despite the fact that we have some different teams going through different operational processes and using different programming languages. We have flexible use of technologies, so each microservice can be written using different languages. That's what I'm talking about just then, where you can have different programming languages in a different component of the application, but because we can speak with a common language, that is the API, that doesn't matter. And speed and agility, so very fast to deploy your components of your application utilizing cloud native features, and it's very easy to building high availability and fault tolerance. A lot of that comes from the underlying infrastructure that AWS deploy. Services like Lambda functions, they already are highly available for us. So all we have to do is set up how we want to be able to scale our functions to allow more concurrency. And the same with running Docker containers on AWS using Amazon ECS. They have a serverless service which takes care of all the high availability for you. And that's what we're going to move on to next. We're going to have a look at the Amazon Elastic Container Service.